Good morning, ladies and gentlemen. It's a pleasure to be here to talk about the fourth industrial revolution and the impact it's having or bound to have on the African continent. What I'm going to be sharing today has more to do with, in essence, an overview of the fourth industrial revolution, but clearly drone technology is a subset of that, and therefore it's obviously very relevant. And also just to say that the fact of the matter is that fourth industrial revolution covers a great many types of technologies, but it's easy to sum it up as those technologies. It's sort of a merger or a bringing together of computing and digital technologies, physical technologies, biological technologies on the back of electronics and coding. Now, the backdrop for this conversation here on the fourth industrial revolution in Africa is that we still have really grinding poverty on the continent. And you can see from this picture, a lot of people still suffer inadequate housing, inadequate healthcare, inadequate roads and infrastructure. And so there's a huge challenge. And the fact of the matter as well is that the state of the African economies in terms of industrialization sits somewhere between the first, second, and third technological revolutions, industrial revolutions, and a little bit of impact from the fourth industrial revolution is being felt, but only starting to be felt. And this means that because the population on the continent is already at 1.2 billion and set to double by 2050, the challenges that we're faced in terms of trying to build our economies are huge, and there's a chance that the fourth industrial revolution might actually widen the gap between African countries and industrialized countries. But at the same time, it may be an opportunity to actually accelerate the kind of development that we need to see on the continent. And I think the examples that we heard earlier today about how drone technology specifically is already having an impact on the continent is a very good indicator of what can happen and what should really happen as long as people who are innovative are able to be as innovative as they can be in order to be able to see this through. A lot of the workforce on the continent is in the informal sector. This is a picture from Kenya. In Kenya, we have about 85% of the workforce in the informal sector. It's higher than most other African countries. And you're finding that these people are engaged in work activities that have very low productivity, not very high income as a result, very low competitiveness with imports. And so we really need to be able to impact how we make things on the continent. This is only one example. The informal sector is a lot wider than just people who are making things, but it's a good example because it tells us that in terms of industrialization, we really have no choice but to be able to make more of what we consume and to do so competitively. I happen to sit on a council at the World Economic Forum called the Global Council on the Future of Production, and we were part of the preparation of a document called the Country Readiness for the Fourth Industrial Revolution. And so we looked at a number of countries across the world and indicated or assessed them to see how ready they were for the future. And this is what's very important here is that even very wealthy and industrialized countries really have a difficult time trying to imagine how the world will look in a year or two or in a decade because of how fast technologies are changing as part of the fourth industrial revolution. So much more the case for African countries. About 25 African countries were included in the survey, and 22 of them are found to have very low readiness for the fourth industrial revolution. So this is something that policymakers, large business, and so on needs to really be able to understand and take account of. An overview of the analysis looked at two things. On the left of that graph, you can see the structure of production, and that's looking at the current status of the various countries that were surveyed, and that's broken up into the complexity, which is captured in the Economic Complexity Index, and this is an index that gives a very good idea about the variety of things that can be made in a given economy. So you look around you, there's simple things like the chairs that you're sitting on, the bottle of water that's ahead of you, the clothes that you're wearing, and so on. On the continent, despite the fact that many of these do not require rocket science, but the economic barriers to be able to make these things competitively on the continent are real and are really serious. And so this is a very good indicator about how ready a nation is, what its complexity index is. The second is the scale. And scale, again, is really important. It's been spoken of several times today that African countries are fragmented. There was that question about drones traveling from one nation to the next and how regulation needs to be aligned so that this sort of thing can happen. And especially where you're looking at investment. Investors want to be able to invest in scalable ideas, and if they can't understand exactly how those ideas will scale on the continent, then the likelihood is that the kind of investment that you need to be able to get the ideas that young people and older people on the continent have will not really be forthcoming. On the right, you have the drivers of production. And if you break that down, you're looking at technology and innovation, human capital, global trade and investment. We're looking at institutional frameworks, sustainable resources, and the demand environment. Now, what I'm going to be speaking about shortly is the work that I do in a center that I run in Nairobi that has an impact on this readiness that I'm describing here. But strictly speaking, what I do really falls between technology and innovation and human capital. So we can innovate and we can prototype and make all manner of things that really look very good. But if the other four, the global trade and investment, the environment, the ecosystem is not dealt with, then you find that the kind of impact that you'd like to be able to see will not be possible. In the country readiness, this is a graph that indicates those countries that are leading in terms of their readiness, those that have high potential, those that have legacy issues to deal with. They've got heavy investment, say, in industries that are about to be overtaken or have been overtaken by more up-to-date, more productive systems and can't just flip and change. And then there's those countries that are nascent. And as I indicated earlier, most African countries fall in the lower left quadrant, the nascent countries. Now, one of the ways in which many African countries have responded to the demand to be able to modernize and to be able to keep up with technology is the creation of hubs. Most of these hubs have been developed outside of government involvement, except for in countries like this where the government is really very proactive. And it's been found that the impact of these hubs is quite significant. In this particular survey that was produced last year by GSMA, you're seeing around 314 tech hubs across the continent. And most of them are focused around software especially. And we all know that the impact of software and digital technologies is very high. And there is a sense, even in terms of in the literature, that the world is right now in a post-industrial era, that perhaps policymakers in countries like in Africa and other parts of the world should not really be focusing on trying to build their manufacturing capacity, because the chances that they'll be competitive and able to compete with, especially the factory of the world, as is often spoken of, China, are low. But I believe that there are important examples that shows that this is not the case. And the application of research and effort towards developing local industries and technologies needs to be done judiciously so that you focus on those that can make a difference and then continue to purchase those technologies that are more effectively obtained from outside as you do this. So we in Nairobi, I run a center called Gearbox. And Gearbox is a center that looks at hardware rather than software. And so we're in the industrial area in Nairobi looking at how we can actually make things. And this graph, before I get into that, is showing why it's so important. You're looking at the total intra-country trade in the East Africa region as just an example from the continent. And you're looking at this trade declining by about 20% between 2012 and 2016. And over the same period of time, underneath the graph, you see the note there that says that imports from China accounted for 22% of total imports to the region. And so a further analysis of whether this is correlated would be important, but I think there is certainly some impact on the fact that a lot is being imported from China in particular, but other countries as well. And it means that, for example, in Kenya, manufacturing as a percentage of GDP has dropped from 11% to about 8% over the last few years. And we need to really be looking to see how to tackle this kind of challenge. At Gearbox, we look at three fundamental ways of doing this. Our core functions are around giving access to people who are innovative around hardware to machines. And these machines are consistent with the fourth industrial revolution. So you're looking at digital design and fabrication, robotics. You're looking even at simple things like the example I gave earlier, how do you make a chair and make it competitive so that it can be sold in the local market instead of being imported, say from Malaysia. And so a wide variety of things. And the people who have ideas and want to come and make the things will do so in our space using a membership model that's very akin to a gym membership. So you pay a certain amount, $100 per month for everyday access, $40 for a couple of days a week. At the same time, we also train in areas, again, that are future-facing, areas such as the Internet of Things and embedded systems, artificial intelligence, digital design and fabrication, robotics, and so on, so that people coming in are able to understand better how to use the machines that we avail and the systems and the methods to be able to produce what it is that they want. And we also have a very strong focus on human-centered design. I've taught at the University of Nairobi in engineering for many years, and I know that engineers are very often guilty of designing or working on things that are a challenge to them, interesting to them, but quite often the market couldn't care less. And so by the time they've solved it, they find that the new problem is that they can't sell what it is they've made. So we have a huge onus on human-centered design. So you're looking to design something, and you don't graduate from our courses until you make what you've proven has, through your research, has a market. We also contract, and contracting is really important. This is where you have people who aren't really interested in making things themselves, but what they'd like to do is, because they've understood the market, they've been out there, they know exactly what is needed, say a water filter or something that specifically has a huge market, and they come in and say, can you make it? And they give us the specifications. And so the engineers in this instance are either our staff members or people on a list that we have who will then go on to develop the idea. And then we look at research, where we're looking at trying to be very deliberate about the areas that we're trying to develop, working with the universities, and trying to see how we can make the universities more directly related to what the market needs. I worked at the University of Nairobi as a lecturer for about 14 years, and that was the inspiration for starting Gearbox, because there was a huge disparity between what we did and what the market required. Now, in recognition of the fact that much of what is required for the fourth industrial revolution has to do with electronics, we decided to invest heavily in the ability to design and make printed circuit boards. So we go from the copper all the way to what you're looking at there, and to devices such as this. This is Omondi, who designed 50 prototypes of a pay-as-you-go system for water irrigation, so that farmers can use solar power for their water irrigation, which is much cheaper than what they're currently using, which is either petrol or diesel, or in some cases electricity. And to be able to do this and go out into the market and test it on the 50 farmers and come back and make all your changes and go back into the farmers and test it again is really important in the pathway to investment, because now an investor can see how it was used and who was able to pay for it, how much, and so on and so forth. And so this was done, typically would take about 6 months, working with a company in China. The company in China would not be, most really good companies in China would not be interested in 50 parts. So you get companies that are probably not very good, don't speak English, huge problems. We had a lot of experience with this. Your 50 devices come and 10 don't work, and that sort of thing. So having this capacity in country is really very important. We also make 3D printers, and in this case, this is one of my students who has a company called Africa Born 3D Printing, and he's making microscopes, and in this instance, he's actually making 20 for a local network of vets in the country. And the design came from an open source group at Cambridge University who make and design various instruments and allow anybody to be able to download and make it. So this is also indicative of what's happening in the new world around technologies, the open source movement as well. We use the same 3D printers to make parts for medical equipment in small clinics, in rural settings, in poor urban settings, where you get an instrument that may have been donated, for example, is fairly sophisticated. There aren't people who understand how to make it. The parts are not available locally. And so we found that it's actually possible for somebody who has been taught how to use the 3D printer to make a business out of this, going in and designing with a micrometer and actually reverse engineering and making whatever parts required using the 3D printer. We have Roy Alela, who his niece was born deaf and mute, and he paired up with the lady next to him who's an electronics engineer, and he's an AI expert, and they were able to make these gloves. So the deaf person puts on the gloves, and they trained through machine learning the system to be able to understand what every gesture means in terms of sign language. And then what you'll do is you'll download his app select male or female voice, and your phone will speak all the words that you're signing. It's been found to work. We partner with the American Society of Mechanical Engineers in an annual competition they hold for the continent at Gearbox, and he was one of the winners and has managed to travel to the US with this. And the government of Kenya has now put about $40,000 behind him. So the National Innovation System is responding to what's happening on the ground in the centers that I described, which is a very positive thing. Here we have the result of a master's project, which was to design a combination or embedded solar cells in roof tiles. And after the young man, Tony Nyaga, got his master's degree, he and his sister, who's an architect, started a company. And what they do is they pitch their roof tiles to people who are doing development, say, of 50 houses, at the cost of just a roof tile without the solar. And then they make their money slowly in a pay-as-you-go model over time. And the person using the electricity that's generated from solar is paying a third of what they'd pay the utility company. So it makes lots of sense to them as well. And we were really proud to be able to share this with this gentleman, Mark Zuckerberg. I won't tell you what he said about it, but his pal, this guy, was able to do, well, did the same thing in the US, the very same design. We've tried to research, and our research so far tells us that they did it after we did. But the problem was that it was patented only in Kenya. So the opportunity to sue Elon Musk has gone. But, but anyway, as I say, the research is not conclusive. Now, this is a video showing a typical production area in the city of Nairobi. It's an informal setting. A lot of people work like this, and they're making products such as those that you see there. Very low productivity, low quality, but there is a market, and so they're still in business, and this is actually giving work to a lot of people in the city. We have been able to design machines that should be able to replace a lot of the people in that picture. And that's the challenge, because this machine is a plasma cutter, CNC, which means it's computer numerical controlled. This is driven by the computer. The engineer who designed it is used to be the head of engineering at Gearbox. He now sells these machines, and he's now doing 6-axis machines for local customers who are really excited because the person selling the machine is local, so post-sale maintenance is available. But what we're trying to do now is take these into the settings that are in informal sectors, and the challenge is that the first thing that happens is hundreds of people will lose their jobs when you put a machine into that setting. So we're looking at how to retrain and so on, so that the obvious increase in productivity, which will mean more money for whoever has bought the machine, will mean that they'll be able to hire people who are currently doing what I showed you in the video to do things that they'll be able to, that are different, that should be able to give them a livelihood. That's a CNC router that can do carving of wood, also made at Gearbox. And this is a pipe bender, which is automatic. And here we've been partnering with the Kenya Commercial Bank Foundation. And the idea here is to make greenhouses. They've been able to establish a market for hydroponically grown food anywhere in the country, in the city, that should be a lot cheaper than buying it from the current sources. There's exciting companies like Twiga Foods in Kenya, some of you might have heard of, that are completely transforming the supply chain and making it cheaper for people to buy the vegetables. And we believe this project will have such an impact. But the beauty of it is that the market has already been found, and so a bank has come in and will loan the people in the informal sector to buy machines or to access them in centers that we're building, and because they're ascertained that the sale will be there, or at least it's been de-risked to the level that they can actually extend loans to the informal sector. So one of the characteristics of an informal sector is that it's broadly not eligible for loans, and therefore growth is a problem. And so we believe that doing things in this manner could mean new ways of pulling the informal sector into the formal sector. And the idea is to be able to also give access to these machines all over the country. So we're setting up mini gearboxes everywhere. We're doing the first one actually starting this week to do so. And we see this model as applicable across the continent. And here is what it might, partially might look like. You have containers that can move around that have the equipment. And you're going from the familiar, so you have welding equipment and so on in the bottom of the container. But then on the top, you'll be teaching, and it's a classroom, the container at the top, and you can teach 3D printing. The informal sector doesn't do plastics forming, mostly in a country like Kenya, and introduce vacuum forming and all kinds of very interesting processes that actually can compete with the formal sector. And we've been looking in a granular way at how it is that supply chains can be aggregated to try and make sure that the competitiveness is available. The younger generation is critical. Here's a young 15-year-old who's just been taught how to disassemble and reassemble a 3D printer, and we're getting lots of them coming in through schools and so on. So that's the model that we have, and we believe that this lends itself to what you heard being spoken about earlier, the need for the drone application to be supported by people who can make parts for drones and maintain drones and so on. And so that's why I believe I was invited to give this particular keynote, because this is a model that can work to support what you're all doing here. Kudos to you all, and those who are in the challenge, good luck. Thank you very much.
Dr. Kamau, thank you very, very much for that keynote address. I must highlight one thing that is very, very important. We talked about Drone Operations Center. I want you to think of a petrol station. A petrol station's core activity is to sell petrol or fuel, or essence for my colleagues. So if they have the petrol station, that's the core activity. We're going to have a Q&A in a moment. If that's the core activity, then you have a room where you have refrigeration. You sell soda, you sell biscuits, and you sell very many other things. Think of a drone operations center as that. Take what Kamau has done, put it in a drones operations center. You service other things, fabrication lab, you have fabrication of small parts, spare parts that can help the motorbike rider. He's got a nut that needs to be fixed. Instead of going into town or he's very far on an island, you have a 3D printer that creates that. So, and this is what we mean about the drone operations and fabrication labs and the drone operations center. But to have all that, you must allow for regulations and have innovation in order to have that done. So as we go to a Q&A, anybody wants to challenge Dr. Kamau here and ask him a very difficult question? He's my friend, Yes, sir.
I'm not sure about that.
After this. Yes, sir.
Thank you. I am Mwanguzi Bernard, a teacher at Gachigi Girls Academy. I'm a teacher of physics and mathematics, but crossing into IT because of the need that I've seen. But mine is just a challenge, not only to Dr. Kamau, but to everyone. All of you are talking about innovation, but when do we start to innovate? Do we have the right education to make our students question in order to bring future innovators? Everyone has been talking about a university, but then they never think about the lower education. At the moment, we still have a lot of content. The students come out cramming that content. Sometimes you don't even want to cram it, but what do you have to do? That's what you need to do in order to pass. So as we are thinking about university and those who come out to have the skills, we should trigger the young generation to have that kind of aspect. Not to think that those who go to skills are the ones that have failed school, and the very bright ones should be the ones who go for a degree and all those other certificates. Thank you very much.
Thank you very much. There is a lull. My stomach is churning, I missed breakfast this morning. So, any last question before we break, not for tea, but for lunch? Going once?
There's one here.
Going twice? Okay, you caught me. Right. Yes, sir.
Hello, Yusuf Abdul Karim Imoga from AMS. So for your roof solution, the solar roof solution that you said allegedly that Elon Musk took away from you, what capacity in terms of output for that on a 20-foot kind of a container? Like when you have that, do you know the value? Like when you have that on a roof like that, what kind of power is it going to come out?
It's typically on the order that is for a typical sort of middle-class family, the way that he's designed it, so that you have your appliances such as your television, your lights.
No, I mean the value of in power, in volts, or watts. What's the output when, let's say, you put it on a roof?
It's like on the order of 3, maybe 5 kilowatts for the kind of things, the thing that he's designing.
Okay, 5 kilowatts.
Yeah.
Okay, thank you very much.
Sure.
So with that, Dr. Kamau, thank you very much for your keynote address. We thank you
Thank
for
you.
coming. Please, a hand for Dr. Kamau.